Hi everyone, hope you are doing well. In this video, we are going to discuss the high-level design of an e-commerce platform like Flipkart. This video is a part of a series called as Software Engineering Bootcamp, and as a part of this series, we are creating multiple videos related to how to set up the system, how to think about various solutions, how to have a pros and cons analysis, etc. So as a part of that series, we have a task to create an e-commerce platform like Flipkart where people can search for the stuffs and then eventually make orders. In the previous video, we have discussed about the requirement that these are the requirement at a very high level, that what are the things which customer should be able to do. So customer should be able to search for an item and then eventually place an order for the item. We are not going to deal with the payments in the version 1 of our product. And we also talked about the persona and how persona defines a particular product track. So in this video, we are going to talk about the high level design, that how exactly the system should look like. Now, just a disclaimer that the intent here is to learn how to build a system and how to think about the system. It's not going to be exactly how a very high scaled system would be there, because here I'm starting with a very simple application with just one backend, one database and one service. That's it. So in the ideal world, I might have a lot of asynchronous flows, lot of Kafka and all those things. So we are not starting with that. We are starting very simple, and then we will slowly evolve the product. So this, imagine it like a version 1 where we are starting with a smaller scale and then we'll scale it later, and that's how the product evolves, right? So how do you design your system, or how do you think about the building of the product? So here we have a few entities in our design. So the first one is product. So whenever you design your product, don't just go to the choice of database on, let's say, first minute, right? First, think that what is your requirement. So the requirement is that we need bunch of things, which means that we need bunch of data, which needs to be stored in the database and maybe in the API responses as well. So the first thing, if you want to sell any product in an e-commerce platform, is that you need to store the information of the products. So we'll have something called as products somehow in the database. How we are going to store is a different story, but we need to store this data. That is a product data, which will have some ID, some name, some category, price, count. That is number of items in the stock and the description. There's a basic information that we'll have. How we are going to store is the next thing which we'll think about. Then people should be able to add the product to their cart. So this is how a cart should look like, that what is the total item in the cart, what is the user ID for which the cart belongs to, and what are the products added to the cart. Now here you see that I have added the product details in the cart here, and it's here again. But we are not talking about the database design. We are just talking about the how would the actual data which is there, which what's the actual data which we need. So the second is the cart information, that people should be able to add product from here. So whenever they add a product to their cart, the subtraction will happen from here. So count will decrement and the item will be added to the cart. So that's one thing. Now you can talk about various scenarios, that what happens if person adds an item to the cart but never checks out. So all those scenarios we are not going to deal in the version 1. Imagine that a person just adds a product to their cart and that sell out if the count is greater than 0. So that's the second thing. The third thing is, once person is able to see the product, they are able to add the thing to the cart, then they should be able to place the order. So there should be something like a order, you can say order entity, order JSON, which will have bunch of information like user ID, date of order, status of the order, address, and the final product. So that would be the third entity which we need to store. And the last one is the user detail, that what is the user ID, email, name. Some people might also want to store password, but we are not storing the password, because the moment you go into the business of storing password, things become complex, because it's a user's very secret data, right? So you have to hash the password. There are lots of videos you can figure out on internet that how to store the password. There is something called as salt, and then there is a hash, and then there are a lot of things you have to do, and you have to be very careful that your data or your password doesn't get leaked. So what we are doing is that we are using login with Google. So In that way, we never have to bother about storing the passwords. So that's why there is no column called as password here. Just ID, email, and name, and then we are good. So these are the things we need to store. Just 4 things: entity, that is the product, the first thing. Then some of the product will be added to the cart, and then some of the carts will be converted to the order. And then the order can be like a successful, cancelled, returned, etc. We can keep on adding. And then the user IDs. So these are the entities which we need. And that should be the ideal way to start your design. Don't go with a database choice initially, because we don't know what type of queries we need, right? So this is the data. And one important thing we see is that there is a bunch of one-to-many relationship between cart item and the product. So basically, if you see here, the product, one product is there, but then we have the array of products. So that's one thing which we need to be careful when we design the database. That, how do you, in some databases, the joins is not very easy. In the other, the joins are easy. So those things also. This is one point which we need to be wary about. Likewise, these arrays. So in the SQL databases, you don't have a list database, right? So you have to have a one-to-many mapping. So that's why I mentioned it. What kind of query patterns which are there which we need? So first is get all products from various filters. So you see the first one is the product. So get all the product. So this getting all the product from the database is supported by all databases. It's not the SQL, NoSQL. Every database supports it. So that's okay. The second one is create a cart with a random ID, then add product to the cart and decrement available item count from the cart. So there are 3 steps which needs to be done. So in these things, whenever there are 3 things, let's say a person wants to add an item to the cart. So you have to decrement the count and immediately you have to create a cart and add an item to the cart. So there are multiple operations you need to do. Basically, you need to do 2 operations. One is decrement the inventory and the second is add an item to the cart. So in those cases, if you want atomicity, that is the data is correct, it should not happen that you decrement an inventory, but you don't add an item to the cart. So if you don't want such thing, then you can use the SQL database. But if you're okay with a little bit of delay, then you can use NoSQL databases. In general, if you talk about the companies at scale, the companies at scale will always have different team for inventory, different team for cart, different team for order, and they might even have a different database as well. Different team or different database for storing the inventory, storing the cart and order. So these all things would happen asynchronously. But since we are in a very nascent stage, we'll just have one database which we will have one table for inventory, one table for cart, and one table for order. So we'll keep it very simple and not like a very high scaled system where things are asynchronous. But you get the idea, right? That if you want atomicity, then you would need to choose certain databases like relational data. I have created one video on the same thing, when to use MongoDB and when to use a relational database. I can pin it as well. But here we are going to use the SQL database and we'll talk why. So the first thing you see, the same thing is written here, that why NoSQL and why SQL, both the things are written. That while initially we might want atomicity, but for many companies, the cross table atomicity is not that important. So all the things which I talked initially. So we'll choose SQL database. We'll start with the SQL database because it's simpler to use. And the thing is that we are starting this tutorial. So I don't want to start this tutorial with lot of asynchronous flows, lot of complex flows. I don't want to start this tutorial with, let's say, Cassandra. So those things I don't want in this particular video. I want this video to be simpler. So that's why I'll use SQL database. I'll talk about how we are going to put things in the SQL database, and accordingly the tables will be created. So there will be user table, inventory table with the same JSON which I talked about, and then the cart table and the order table. So these 4 tables will be there, and there will be a bunch of foreign keys as well. For example, if you have a inventory or product, so product ID will be a foreign key to the inventory. So those things will be there. It's very complex, but just a thing which we should be aware of. I'll have a certain video where I'll actually create these schemas, so you'll have more clarity. But I'm starting with the SQL database because it's an initial phase. We just have one database with one table to get everything, one database with multiple table to get things done, and not multiple databases and multiple teams and all those things. So the only reason we are choosing it is because we want to start simple. We want to have a smaller scale in the beginning, and there things will be just fine. Even SQL is very much scalable. So it's just a myth that SQL don't scale. They scale well. There are use cases for various databases. So unless this SQL database is not able to solve our use case, we'll not move to some other database. But then again, system design, whenever you study, you will know about the various use cases. The design diagram, let's talk about the design diagram in the next video. I think for this video, I just wanted to justify the choice of database which we are going to make. There is no right and wrong choices. Various companies have implemented their system with various approaches, and all of them are working fine. So yeah, that's it from my side for this video. In this particular video, we concluded that we are going to use Azure SQL database. That is, we are going to use SQL database. SQL database will support atomicity. Since the scale is initially small, so even if I have to take a few joins, it will be fine, and I don't have to worry much that, let's say somebody asks for a given card, what is the something. So we might need to take joins, and joins are okay in the SQL database at a smaller scale. So that's why we are choosing this. And the third is definitely the learning part. So we want to start learning with the SQL one. So that's why. So yeah, that's it from my side for this video. I hope this video was helpful. Whenever you take a design decision, always don't start with the database on first minute. Start with the type of APIs you want to support. Accordingly, write down what are the types of queries you need from the database. And you will get some hint that, okay, do I need a lot of aggregate, or what type of queries are there, so that it will be easy for you to guess or make the right choice. So yeah, that's it from my side for this video. I hope this video was helpful. Till the next time, bye.